Hi there. I'm glad you were able to join me for this video. We're going to be solving some radical equations. I have this little how-to box in case you want to screenshot it or copy it down in your notes. It's how to solve an equation if it's a radical equation. So here are the steps. You can simplify these, you can use them as is, or you can ignore them altogether. But it's important to have a process, right? So the first thing you want to make sure you do is you isolate the square root or the radical on one side of the equal sign. So in other words, get the square root by itself. Get the radical by itself. If the radical is a square root, then you square both sides of the equation. You're going to use the exponent to get rid of a root, because remember that exponents and roots are inverse operations. So if you're starting with a square root, you square it. If you're starting with a cube root, you cube it. Whatever your power is will match your root. And remember that this is a square root, it's understood to be a 2 there. So whatever power you have, if it's like a 5th root, you will be raising it to the 5th power to undo the 5th root. So your exponent will match your radical, your index. Then, once you get rid of your radical, you're going to solve the remaining equation. If a radical term still remains, in other words, if you have more than one radical in your equation, you're going to have to start these steps over again and do it all until you get rid of all of the radicals that are in your equation. And then it's really important that you do step number 5. Confirm your solutions. Easier way to say this is check your answers. So check. Because the answers that you get may not actually be answers. Sometimes you get what's called extraneous solutions, extra solutions basically, that aren't actually solutions. And when you plug them in, you'll see that they don't actually work. This happens because when you're squaring something, it kind of eliminates the signs, and so you may get something extra that won't work. And when you check it, you often see that the problem is that the sign is wrong on one side. So let's look and see if we can use these to solve the equations. So number 1, of course, I started very, very simply. And so for this one, you could even think about the answer on your own without solving it. What could I put in here that would make this true? I'm asking the square root of what is 3? And so you may already know it's 9. But if I wanted to show the steps, the first thing I'm checking to see is the square root by itself on one side of the equal sign? Yes, everything on the left is under the radical. So at that point, I can undo the radical by raising it to a power. Since it's a square root, I'm going to undo the square root by squaring it. Whatever I do to one side of the equation, I have to do to the other. So I'm going to square both sides. The square undoes the square root and just leaves x on the left-hand side. And 3 squared is 9. I can check it, so I might as well get in the habit of doing that. So check x equals 9. Square root of 9 is equal to 3. Well, the square root of 9 is 3, so it works out. So this is, in fact, a solution. Number 2. First thing I look at is the square root by itself on one side of the equal sign? Yes, everything on the left-hand side is underneath the radical. So at this point, it's good to get rid of it by squaring. Since it's a square root, I undo that with a square. So if I square both sides, the left-hand side is just going to be 3y minus 1, because the square undoes the square root. And on the right-hand side, 2 squared is 4. I now have a simple linear equation, so I can solve it by getting the y by itself. So I'm going to add 1 to both sides, and I get 3y equals 5. Divide by 3, so I get y equals 5/3. I think that's a solution, but in order to know for sure, I need to check it. And I'm going to put x, but I should be putting y. So I'm going to check y equals 5/3. So I'm just going to plug that into the equation. So 3 times y, so I think y is 5/3, minus 1 is equal to 2. And then I'm just going to see if I get a true statement. So 3 times 5/3, the 3's divide out, and that would leave me 5 minus 1 under the square root. 5 minus 1 is 4. The square root of 4 is 2. So I have the equation 2 equals 2. 2 equals 2. So that's true. So that is a solution. Let's look at number 3. So number 3, first step, is the square root by itself on one side of the equal sign? The answer is no. I've got this, whoops, sorry about that. I've got this 13 over here that's not under the square root. So that has to go before I square. That's very important. If you don't remember that step, you're going to end up messing something up. So minus 13 from both sides. So that's going to give me z minus 8 on the left, square root of z minus 8, is equal to 25 minus 13 is 12. Now everything on the left is under the square root. So the square root is isolated. So it's time to square both sides. When I do that, it gets rid of the square root on the left. So I just have z minus 8. And 12 squared is 144. And now I'm going to solve by getting the z by itself. So add 8 to both sides. So z equals 152. And now, don't forget, you have to check. So I'm going to check z equals 152. So I have the square root of 152 minus 8 plus 13 is equal to 25. So I'm just going to simplify the left-hand side and see if it's 25. So 152 minus 8, that would be 144. The square root of 144 is 12. And then 12 plus 13 is 25. And on the other side, I'm just continuing to bring it down. And so I get the statement 25 equals 25. That's true. So this 152 is a solution to the equation. Okay, let's look at number 4. First step, is the square root by itself on one side of the equation? Yes, it is. The whole left side, it's all under the square root. So at that point, I'm ready to get rid of the square root. So square both sides. Square undoes the square root. So on the left, I'm just going to have 2x plus 24. And on the right, I'm going to have x squared. Now notice this is different. 1, 2, and 3, once I squared both sides, I ended up with a linear equation. But here I have a quadratic equation because I have the x squared. So I have to take a different approach when I'm solving this. If I'm trying to solve a quadratic equation, you want to get everything to the same side and set it equal to 0 so that you can try to factor or you can use the quadratic formula. Since x squared is positive where it is, I'm going to move everything over to be with it because I want my x squared to be positive. So I'm going to subtract 2x from both sides and subtract 24 from both sides. So that's going to give me a 0 on the left and an x squared minus 2x minus 24 on the right. And if you're used to seeing the 0 on the right, that's fine. You can rewrite it. Now I'm going to try to factor this. So let's see what I get. And I'm going to rewrite it with a 0 on the right. X squared breaks down into x and x. The negative in front of the 24 tells you you're going to have different signs. So 1 minus, 1 plus. The numbers that multiply to get negative 24 and add to get negative 2 are 6 and 4. So we have these two linear factors that we can set equal to 0 and solve. So x is 6 or x is negative 4. So this time we have two possible solutions. And remember, we have to check both of them. So let's check the first one we got, x is 6. Let's check that first. So we have the square root of 2 times 6 plus 24, and we want to know if we end up with 6. So I'm plugging in 6 in both of the x positions, and then I'm going to simplify. So 2 times 6 is 12. 12 plus 24 is 36. And then the square root of 36 is 6. So 6 equals 6. That one works. So that's a solution. Now I'm going to check the next possible solution, and that is a -4. So I have 2 times -4 plus 24, all under the square root, and I'm hoping that that's equal to the -4. So 2 times -4 is -8. -8 plus 24 is 16, and the square root of 16 is 4. And I have 4 equals -4. You see how it's only off by the sign? That happens with your extraneous roots. So -4 is not a solution because I did not get a true statement. This is false. 4 does not equal -4. So the only solution to this equation is 6. So make sure you check your solutions. All right, so the next one, we have number 5. Here is a link to the OpenStax textbook. This is where I got some of these equations from. It's where I got that box at the top with the steps. And you can find other, examples and explanations. It's a good resource to have. So number 5, we're going to do the same steps. First, we want to check to see if the square root is by itself. It is. So at this point, I can square both sides of the equation. So on the left, I get x plus 7. And on the right, I have to actually write that x plus 1 down twice and distribute. Don't make the mistake of just saying x squared plus 1, because you will be missing the middle pieces. So x plus 7 is equal to x times x is x squared plus x plus 1 when you distribute or FOIL it out. The middle two terms are like, so you have x plus 7 equals x squared plus 2x plus 1. Again, we got a quadratic equation, so I'm going to move everything over to the side where the x squared is because it's positive. So I'm going to have 0 equals x squared plus x minus 6. And then I'm going to try to factor this one. It looks like it's factorable as well. So we will have x and x. Signs are different, so 1 plus, 1 minus. 3 and 2, those will multiply to get me a -6 and add to get me a positive 1x. And then each factor will lead to a possible solution. So one possibility is a -3 and the other possibility is a positive 2. And now we're just going to check those. So let's see. Check -3. So we have -3 plus 7 under the radical equals -3 plus 1. So -3 plus 7 is 4, so square root of 4 equals -3 plus 1 is -2. Square root of 4 is 2. So is 2 equal to -2? No. So -3 is not a solution. Now let's check 2. So if I check 2, I'm going to have the square root of 2 plus 7. And I want to know if that's the same as 2 plus 1. So 2 plus 7 is 9. And the square root of 9 is 3. Is that equal to 3? Yes. So 2 is the only solution this time. So -3 is an extraneous solution. It does not check. So it's very important to check on these. Some of the other equations that you solve, checking is optional, but it's required here because you often will get extraneous solutions. And if you don't check and you say that both of those are your answers, you're going to end up missing some or all of your points, depending on how your teacher grades. So for this one, number 6, first we want to see if the square root is by itself. It's not. So we need to start by getting rid of whatever is not under the radical. This minus 1 is what is not under the radical. So we'll start by adding 1 to both sides. So we get the square root of 10x minus 15 is equal to x plus 1. And so now at this point, we do have the square root by itself, so we can square both sides. So squaring both sides will give me, and I'm going to kind of shift to the left because I'm afraid I'm going to run out of room here. So 10x minus 15 on the left-hand side, because the square undoes the square root. And on the right-hand side, we need to write the x plus 1 down twice and FOIL it out. Now we just did this in the previous problem. So I'm just going to point out here, we just did x plus 1 squared, and we saw that it was x squared plus 2x plus 1. So I'm just going to skip to that step because I've already done the work. Again, I see that I have a quadratic, so I want to move everything to the same side and zero it out so that I have a 0 on one side. So I'm going to end up with x squared minus 8x plus 16 is equal to 0. It looks like it might factor, so I'm going to try that. Remember, if it does not factor, you can use the quadratic formula. So the 16 is positive. That means my signs are going to be the same. Because the 8's negative, it means they're both going to be minus. 4 times 4 is 16, and 4 plus 4 is 8. So that's going to be what works. Since it's a repeated factor, I'm going to solve them both, but I'm going to get the same thing. I get x is 4. So there's only one possibility. X could be 4, or there's no solution. So let's check and see if it checks out. So I have the square root of 10 times 4 minus 15, then minus the 1 equals, instead of x, I need to put in 4. So 10 times 4 is 40. 40 minus 15 is 25. Bring everything else down. Square root of 25 is 5. 5 minus 1 is 4. 4 equals 4 is the statement at the end. It's true. So x equals 4 is my solution for number 6.